Hi there. In this video, we're going to actually start using trigonometry and those trigonometric ratios or functions to actually find missing or unknown sides. And so we're going to look at a special case where we have a right triangle and a given angle, but and another side of a triangle. But that's a very common situation to be able to measure a length and measure a side. Measure an angle, sorry. And so it's a special case, but it's a very common case, and it'll lead us into being able to solve more general geometric problems based on shapes and on angles and lengths. Let's go ahead and get started. Now, to get started, one thing to understand is in the last video, I would talk about the trig functions of some unknown angle theta. I didn't give you that, and the point was that we were just trying to get the basics down of the trig functions, their definitions. Okay, but at least one angle is usually known. Okay, there are cases where we don't, and we can use trig to find them. I'll talk about that in the next video. But the angle's usually known. So we might have a picture that looks like this. Okay, and so we'll be given that angle, say it's 32 degrees. Okay, now once that angle's known though, then we can actually evaluate the trig functions of that angle. Okay, like that. And so, you know, if we need to use the sine, we'll see why in a minute we might want to use these, but we could actually on our calculators type in the sine of 32 degrees. Now when we type them in on our calculator, we won't need to type that degree right there. I'll show you how to set your calculator up where it knows it's in degrees. Okay, or we might need to know the cosine of 32 degrees, or we might need to know the tangent of 32 degrees. Okay, so first let's see in our calculators just how to get those. Okay, so to get started, first of all, we need to make sure our calculator is going to be calculated in degrees. And so the first thing you need to make sure of, it doesn't matter, most calculators work the same way. Somewhere there's going to be this mode key right here. All right, and so you hit that key, and then notice down here at this line, mine is set in degree mode, so it says degree and it's highlighted. All right, there's another unit that we'll work with called radians later. We don't need to worry so much about that now. And so what you need to do, if degree isn't highlighted, you need to scroll down and then highlight degree. Now, like I say, it doesn't matter what calculator you use, but some calculators might be different. So you might have to look, you know, a lot of calculators have a little information card that they come with that'll tell you how to get in your correct mode. Or you might need to look up online the manual or for some help. Okay, but after you have that degree highlighted, you can hit quit. Okay, and then you can type in like sine 32, like we were talking about. And see, notice that that's a long decimal number. I'll explain that in a minute. But the key thing to understand right now is that we can actually get decimal approximations for that. Now be very careful. I'll mention this again in a minute once I get back on my regular screen. But although we can get the decimal versions of these, don't in a given problem, don't calculate this and round it somewhere and then use that rounded number. Okay, and I'll show you that. But whenever we go and do calculations at the end for our answers, we'll usually just type this in at the answer line when we're trying to get the answer. That might make a little bit more sense in a minute once I can show you some stuff. All right, so make sure to type those in and see that you get those same numbers. Now I'm going to write down an approximation for these to 4 places. But so the sine of 32 would be about 5.5299. The cosine of 32 is about 8.8480. And again, if you're not getting those numbers, you didn't get it set in the degree mode correctly. Make sure to do this. And to 4 places, that tangent actually rounds in its last digit. It's 0.6249. Okay, now I'll often write down some approximation if I need it, but the key thing is don't use this number in a calculation though, and I'll show you what I mean in a minute. Now the reason I wrote these down though, I just want to kind of show you what this means. All right, and so remember we're talking about similarity ratios whenever we're talking about trigonometry. So if I have a right triangle that also has an included angle of 32 degrees. Well, from that 32 degrees, this would be the opposite side, and this would be the hypotenuse. So remember, sine has to do with opposite over hypotenuse. All right. Now, if you think about this, is all an approximation, but if you think about decimal values, This is 5,299 over 10,000, like that. So what that's saying is that in a right triangle with an included angle of 32 degrees, the ratio of the opposite to the hypotenuse is about the same as 5299 over 10,000, or too many nines, 5299 over 10,000. That's not terribly important for us, but just I'll often get students asking me what the heck that number means, and so I just want to point out. And same thing over here with the cosine. If I have a right triangle with an included angle of 32 degrees, remember cosine deals with adjacent over hypotenuse, and what it's saying is that any right triangle with a 32 degree angle, included angle, the ratio of the adjacent to the hypotenuse is roughly 8480 over 10,000. Okay, and you can see that one reduces. You could even get a better ratio out of that. Make sure you, one other small thing that kind of gets people's brains wrinkled every once in a while is this is actually an approximation right here. This number is actually irrational. That decimal goes on forever without repeating. So this is just an approximation. We don't ever get it exactly, and that's the importance of not using these numbers to actually calculate with. Often they'll end up to answers that have some rounding error in them. All right, now we're ready to start using trig to actually find stuff. Okay, so what we're going to be talking about is finding an unknown side, given that A, we have a right triangle, B, at least one angle is given, and at least one side is given. Okay, now what I'm going to do, there's kind of a process that I like you to use whenever you're first getting this down, and it just avoids a lot of mistakes. But I'm just going to show you through an example right now, and then we'll outline that process on the next slide. So let's stick with that 32 degree angle. Okay, so I have a right triangle. Remember, this is denoted telling me I have a right triangle, and then I have one other angle. What else do I need? I need one side given to me. So say I know that the height here is 15 inches. Okay, and say I want to find the hypotenuse, so I want to find x. Okay, I kind of gave a little bit away there. I told you what side x is without doing the labeling first. Okay, so the first step you want to do is you want to label the sides with reference to the angle. Remember how you label opposite and adjacent depends on where your angle is, where your given angle is. Okay, so remember how this works. Here's your right angle. The hypotenuse is always opposite the right angle, and so x is the hypotenuse. Okay, like that. And then here's my angle. Its opposite side is right here, so that 15 is the opposite. Okay, and so this third side would be the adjacent. All right, so those are the labels for the sides. So we want to label the sides. Okay, and then identify in terms of sides by the labels what you're given and what you want to find. Okay, so notice that we're given the opposite side. And then you want, what are we trying to find? We're trying to find the hypotenuse. Okay, this is very important right here. Some people try to shortcut the process and then they make mistakes. They end up using the wrong trig function to solve the problem. After you've identified what you're given and what you want, then first of all, we're only going to work with the three basic trig functions, sine, cosine, and tangent. So then identify, I'll say the basic. What I mean by that is the main three. The basic trig function that relates those two. Okay, and so what do I mean by those two? We're given the opposite and we want the hypotenuse. So ask yourself which trig function relates the opposite and the hypotenuse. That would be sine. Okay, like that. And so next thing we're going to do is we want to write the definition of that function. Okay, like that. And so remember from last video, the sine of theta is equal to the opposite over the hypotenuse. Okay, like that. And then we want to fill numbers in and solve for the unknown. Okay, like that. So see, this is what's a little bit different than last lesson. We know what the angle is. The angle's 32 degrees. And so I can fill that in. Okay, like that. And then is equal to the opposite. The opposite is 15, and the hypotenuse is x. Okay, now what we're going to see, this is actually a proportion. Because we, remember, a proportion is a fraction equal to a fraction, but it looks like we don't have a fraction on the left side. But remember, whenever when we don't have a fraction, we can always write it over 1 to get it in fraction form. I ran out of room and I didn't want to have to squeeze things in. So we left off right here. We have the sine of 32 over 1 equals 15 over x. So remember what we can do. We can equate the cross products. Okay, like that. And so just to remind you of what the cross products are. Again, if you really need to, you can calculate this and fill in the decimal if this is really bugging you. But just remember, this is a single number, okay? So you don't need to worry so much about what it is if you can remember that. And so our two cross products are this sine of 32 and x, and then this 15 and the 1, okay? Like that. And so to equate the products, I would have x times the sine of 32. You can write the degrees, or if you just remember that you're in degrees, that's fine. And then we have 1 times 15. Okay, so we have x times the sine of 32 degrees is equal to 1 times 15 is 15. Now, again, just remember this is just some number, and we're trying to solve for x. So think about an equation that looks like, it looks a little bit weird, but if I had x times 4 equals 16, like that, how would I isolate x? I would divide by the number in front of the x, or in this case, behind the x, all right, to get it isolated. So same thing here. Since I'm just multiplying by x by a number, but I want to isolate it, I would divide both sides by the sine of 32 degrees, okay? Like that, all right? And see here, they'll cancel. And so what do we have? We have x is equal to 15 over the sine of 32 degrees. Okay, like that. Now the thing is, because to actually write to get the decimal of this, I would have to approximate it. All right, and so then whenever I divide it, I'm going to get an approximate answer too. So this is actually right here. This is the exact answer. I can't do any better than that. And so if you remember, I personally like you to always give the exact answer and the approximate if you can. Or give the exact answer if you can, and then also the approximate. Okay, so now to get the approximate though, now we want to get an idea. If you were actually solving this problem, if you were working and someone asked you to determine that length for them, and you told them, oh, it's 15 divided by the sine of 32, they might kind of roll your eyes at you. All right, and so now we want to actually get the answer to this problem. So now on our calculators, we just type in what we have written. So we do 15 divided by sine. Now you don't have to type the degree mark in though. Since we set it in degree mode, our calculator is calculated in degrees. And so right there is going to be our approximate answer. Okay, and so it just depends on, the assignment and how many places you're told to approximate to. Let's say I told you to give that to 2 decimal places, then to 2 decimal places, where this is our rounding digit if we round. So remember, we look 1 digit over. That's bigger than 5. So this is going to be 28.31 is what we want to put for our approximate answer. And so we would say x is about 28.31. And then remember, if a problem has units in it, we want to include them. So we would say 28.31 inches. And that would be the value of the unknown variable x. All right, so let's just summarize what we just did. So we're finding an unknown side, given that we have a right triangle, one angle is given, and one side is given. And I would highly advise following these steps, especially as you get started. As you get more comfortable with it, you can, of course, shorten it once you get more comfortable, but it's just so easy to make silly mistakes here, okay? And so what were the steps? So remember first that we label the sides. Remember, the opposite and adjacent depend on what angle we're talking about. So we're talking about with reference to the given angle. All right, like that. And then we want to identify what we're given, what sides are given, and what we want to find in terms of the labels, okay? And I'm talking about opposite, adjacent, and hypotenuse, okay? And so I'll write that to help you. So whenever I'm talking about the labels, I'm talking about these labels, okay? Like that. And then you want to identify the trig function that relates them. Okay, and I'm just talking about the three basic trig functions, so sine, cosine, or tangent. Okay, we could use the reciprocal functions. The thing is, our calculators don't have keys for the reciprocal functions, so you got to be a little bit trickier with them, and I'll explain that in a later video. All right, and then once you have the trig function identified, then you just write its definition. Okay, and so what I mean by that is, like, if you're talking about the sine, like we did in that example, we'd say sine theta equals opposite over hypotenuse, if that step's not clear. All right, like that. And then once you have that, then you just fill in numbers slash variables and solve. And you can always solve these as a proportion. Some of you that are a little quicker will see shortcuts as you do some of them. But those are the steps right there. Okay, and so whenever we want to find a missing side, given that it's a right triangle and we're given a side and an angle, we can follow those steps and we can always find what we're looking for. Okay, so here's a good example to get us started. I would highly advise pausing right now and see if you can follow those steps and get the answer that we're about to get. All right, so hopefully you paused and you can see if you have the process down already. Okay, but remember the first thing we want to do is label the sides. And so here's our right angle, so this side opposite it will be the hypotenuse. So there's the hypotenuse. And then here's my given angle in this problem. And so this side x is the opposite. So there's my opposite side. And then the third side will be the adjacent side. So this 10 meters is my adjacent side. Okay, so we have our labels. What's the next step? Is that we want to identify what we're given and what's unknown, or what we want. Let me say it that way because there's another side that's unknown. So what we're given and what we want to find in terms of the labels. And so we're given that 10 meters. And see, so it's easy if we do the labels first. We're given the adjacent. So we have the adjacent. And what do we want to find? We want to find x, which is the opposite side. All right, and then we want to identify the trig function that relates those two. Okay, and so what trig function relates the adjacent and the opposite? And hopefully you're getting used to them enough where you can see that's going to be the tangent. All right, like that. Now that's very important. If you're still having trouble with that, you might need to go over those, maybe make flashcards, at least for the three basic trig functions for now. But it's very important to know those trig functions, that sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent's opposite over adjacent. Okay, and so then once we have them, those two identified, or we have our trig function identified, we just want to write the definition. Okay, and so if you remember, I just said it too. The tangent of theta is equal to the opposite over the adjacent. Okay, like that. And so now we just fill in and solve. All right, and so we're given the angle, so the tangent of 61 degrees is equal to the opposite, which is x, over the adjacent, which is 10. All right, and if we treat this as a proportion, now we're ready to solve. We can equate the cross products here. So here's one cross product, here's the other cross product. And so what do I get? I get 10 times the tangent of 61 degrees is equal to 1 times x. Okay, but 1 times x is just equal to x. So see, we don't have any further solving to do on this one. We know the answer, the exact answer is 10 times the tangent of 61 degrees, and then we can get its approximation just by plugging it in like we did before. So we type in 10, 10, 61. Remember, you don't need the degree mark on your calculator. And we get about 18.04. Okay, like that. And then remember to include units. The units up there are meters, and so we would put the meters on the answer. And then that's my answer. Okay, now we can find both missing sides in a problem. If we're just given a right triangle with an angle and a side, we can find both of these missing sides. But the key thing is we have to solve separately. All right. Now, for the second, once we find one side, if you think about it, since we have a right triangle, we could have the Pythagorean. We could use the Pythagorean theorem to find the other missing side. I don't advise doing that because I like you to check problems. And so what you can do is you can find both of these with trigonometry, and that gives you some extra practice with the process too, and then use the Pythagorean theorem to check. Okay, and that's the way I advise doing things. Okay, but the process will be the same. Is that first of all we need to label the sides. I got ahead of myself there. So we still want to label the sides in terms of hypotenuse, opposite, and adjacent. So here's my right angle. Here's its opposite side, so that's the hypotenuse. All right. Here's the given angle. Here's its opposite. This is its opposite side, so x is the opposite, and so that would make that 15 the adjacent. Okay, like that. Now, in terms of the labeling, we got to do these two separately. So let's just pick a side to find first. So let's find x first. Okay, and then in terms of what we're given the adjacent side. And what do we want to find? Since we're finding x, we want the opposite side. So then you remember the next step is you identify the trig function that relates those two sides. This is like the last example. We're going to use the tangent right here. Okay, next step is to write the definition. Tangent of theta is equal to the opposite over the adjacent. Like that. And see, whenever, especially as you're first learning this, the more steps you skip, the easier it is to make a silly mistake. You know, it's easy to reverse these two around in your definition. If you don't even write this, that if you just start filling in numbers right here, then it's just so easy. I've seen it hundreds of times. Or to use the wrong definition, you know, you might accidentally think opposite over hypotenuse. So, you know, write those definitions and then fill numbers in. Okay, so the opposite side is x, and the adjacent side is 15. Okay, you can think about this as being 1. So my cross products are going to be 15 tangent of 22, those are degrees, equals 1 times x, so we get x. All right, like that. And so x is solved. We have x is 15 tangent of 22 degrees. And then to get the approximate, we plug that in. And I would advise practicing this. Make sure you don't make silly mistakes once you get to the homework. And so we have 6.06, and those are feet. Okay, so there's x. And now what we do for y is we just repeat the process for y. So now we're going to find y. We just pretend like we're starting all over. Okay, and so we just start with what we're given and what we want to find. Again, we're given the adjacent, but now we want to find the hypotenuse for y. Okay, well, which trig function relates adjacent and hypotenuse? That would be cosine. All right, and then we write the definition. Cosine of theta is adjacent over hypotenuse, like that. And so we have the cosine, our angle is 22 degrees, and then the adjacent is 15, and the hypotenuse is y. All right, and so we write that over 1. So now when I equate my cross products, I'm going to get y times the cosine of 22 is equal to 15 times 1, which is just 15. And so remember, to solve for y now, I would divide both sides by the cosine of 22. Like that. And so what are we going to get? We're going to get y, the exact form is going to be 15 over the cosine of 22 degrees. And then to get the approximation, I would type that in. So we got 15 divided by cosine 22. And we get about 16.18. And again, those are feet. All right, like that. All right, and so those are our answers so far. Now we may have made a mistake somewhere. So the important thing is to try to check these. Okay, and so I'm out of room. I'm going to have to do this on the next slide. Now there's some basic things you can do for checking too before we actually really check it is notice y is the hypotenuse, so it should be the longest side. So here I have 15, here I have 6.06, and this is 16, so that makes sense. Also, if you think about it, this angle up here, the angle that we weren't given right here, that would be 90 minus 22, that's 68. So the right angle is your largest angle. This is the second largest angle, and this is the smallest angle. So the sides should follow that same correspondence. This being the smallest angle, this should be the smallest length. This being the second smallest angle, this should be the middle length or the second smallest length. And then this should be the longest length. And notice that we have that. X is the smallest. The 15 is the middle value. And then y is the largest value. All right, and so there's little checks you can, well, and you know, this one's pretty obvious of that all, but you can catch errors just by making sure of that kind of stuff, because sometimes we just make a silly mistake. We multiply instead of divide or something like that. And so you can just get a quick look to at least see if things seem reasonable. And then let's see how to really check this. All right, so to really check this, since this is a right triangle, it should follow the Pythagorean theorem. So what should we have? We should have that x squared plus 15 squared is equal to y squared. Now, we don't know that for sure yet. Okay, now be aware, I'm going to check this with the approximates, but anytime you check with approximates, things won't come out perfectly, so they'll come out close. And if they're not close enough for you, you might need to write down more decimal places to actually verify that. Okay, but the reason I wrote the question mark is we're not sure we're correct yet. We're trying to get evidence that we're correct. And so what we want to do is we want to fill things in. Let's try it with these approximates here. So if we're correct, 6.06 squared plus 15 squared, at least approximately, should equal 16.18 squared. Okay, now what we do is we compute each one of these sides separately. Okay, so first on my calculator, I type in 6.06 squared and then plus 15 squared. So I'm computing the left side, and that is, on my calculator, it gives me about 261.72. Okay, and again, we're still wondering, I should have written a question mark there. All right, and then I'm typing in 16.18 squared on my calculator, and that gives me 261.79. Okay, and so that's reasonably close. I would probably be okay with that check right there. Okay, but if you're not, if you're not completely convinced, you know, if you really want a better check, you got to go back to your calculator and look at longer versions of those answers. So the long version of x was 6.0609039 3388. Like that, and so you could type it in like that and get a better check. I just thought too, as I was typing, some nicer calculator features that we can use to actually get a good check, and it'll help you for some more complicated kind of calculations we're going to do later. So let me show you that. All right, so here I am back on my calculator, but let's go back to where we computed x, typed in x. All right, so 15 tangent of 22, like this. Okay, and then I got the answer. Okay, if you think for some reason you might want that number later, you want to save it, there's a key on your calculators. It depends on how new your calculator is, or what kind of calculator is, but every calculator has some key that says STO, and that means to store that value. All right, and so if I hit that key, notice it says the answer, which is going to use that answer right there, and then there's this arrow, and what this allows me to do it allows me to give a letter name to that side. Okay, and so the only thing is, if you're going to use this, do not use X or Y to give a letter name to it. It can mess up some of the graphing capabilities. All right, and so what you do, at least on the graphing calculators, is you hit the alpha key, and see, if you notice up here on the keyboard, there's all these letters, and so those are names that we can give to that number. All right, so I'm just going to call it A, like that. Okay, And so notice now, if anytime I type the letter A, it's going to fill that in. So like if I needed for some reason to multiply A times 5, I could just type in 5 times A like that, and it would give me, it would do that, okay? Like that. And then the other number that we got was 15 divided by the cosine of 22. Oops, didn't hit my other 2. All right, and even if I know I'm going to store it, you can do what I just did, hit enter and then tell it to store. But if you know you're going to store it anyway, you can just hit store and give it a name. And since y is the hypotenuse, again, don't use x and y to store to. So let's just call that h. All right, like that. Okay, like that. Now, if we did our work correct, then this squared plus 15 squared should equal this squared, right? Like that. And so what I can do, instead of typing in that 6.06 like I did, I can just tell the calculator to do a squared. All right, like that. And what it's going to do is it's going to square that entire number right there. And then the left side was plus 15 squared. So I'd want to hit enter. Again, there's that 261 we were seeing. And then for the right side, instead of typing in the 16.18 and squaring it, I can just tell it to do h squared. Like that. Okay. And see, now notice that those things are checking perfectly. And so now I know my answer is correct. All right. And like I say, knowing how to use the store key is actually really helpful for things we're going to do later, because we'll get into really complicated calculations where we're going to have to use numbers through a sequence. And so having them stored will help you keep up with them, especially if you type something in incorrectly and realize it later. All right, hopefully now we're starting to get the basics of it, so we want to start looking at some more practical situations, and we'll start with some basic math and geometry ones, but then we'll look at some actual word type problems. All right, and so if you look at this figure here, I have now make sure you realize this is not a right triangle here, and so but we have these two included angles, 43 degrees right here and 24 degrees right here. And then this line right here is called an altitude. It gives us the height of the triangle, but it's 3 feet. Important thing to notice right here is that altitude forms a right angle with the base. Make sure you realize that that also means that this is also a right angle, okay? So that's going to end up being key. And that's the key thing. Right now with our trigonometry, we only know how to work with right triangles, okay? But we need to find this length of this triangle that's not a right triangle. All right, so we need to break things into right triangles, and you can kind of see there, all right, where they would come from is that I can break this thing into 2 right triangles. I have this right triangle on the left, its height would be 3, and this angle would be 43 degrees. And then I have this triangle over on the right. This base angle down here is 24 degrees, and that height again is the same thing, 3. All right, and if you look carefully, these 2 bases right here are here and here in the figure, and they would compose x. And so let's just call this A and this side B, and then make sure to realize to find x, I would just add those 2 together. All right, and so the key thing is we got to find these 2 things separately. And so for A, we are given, let's see, let's label sides. Sorry, I got a little bit ahead of myself. Here's my right angle, so there's my hypotenuse. All right, we're given that base angle, so here is the opposite there. Okay, and then this third side is the adjacent. Okay, and so we're given the opposite, and we want the adjacent side. So once again, we'll use the tangent with that, and so we write the definition. Tangent of theta is equal to opposite over the adjacent. By the way, you can see that the tangent, it shows up in a lot of more practical types of problems. Not to say well, in a sense, it is the most common one they end up needing to use, but don't always assume you're going to be using it. Okay, and so we got the tangent of 43 degrees. We're filling in numbers now. The opposite is 3, and the adjacent is A. All right, we write that over 1. We equate the cross products, so we get A times the tangent of 43 degrees is equal to 3 times 1, which is 3. And then to isolate A, we would divide by the tangent of 43 degrees. Okay, for now, because we're going to want that exact answer, let's just leave A as this, okay? Because its approximation isn't terribly important for us at this point. So let's just leave it as that. Okay, like that. And that's the important lesson, because if I got the decimal for this and then I rounded it, and then once I went to go and compute x, if I plugged in that rounded number there, I might get some error depending on how many decimal places you're asked to give the answer to. Okay, and so then for b, we got to label it this triangle side, and so here's my right angle, and so the side opposite it is the hypotenuse. All right, and then here's my given angle, and so again 3 is the opposite side. All right, and so that makes b the adjacent side there. Okay, and so we're given the opposite again, and we want the adjacent. Don't always assume that happens. We saw a problem earlier where we needed to use a different trig function for each part, but here we are. What relates the opposite and the adjacent? The tangent. So once again we write tangent of theta is equal to the opposite over the adjacent. I know it seems repetitive, but it helps get those definitions in your mind, in your brain, if you just keep writing them for a while. All right, and now we fill in numbers. So we have the tangent of 24 degrees is the opposite, which is 3, over the adjacent, which is b. All right, we go through the same steps, and hopefully you see we're going to get b is equal to 3 divided by the tangent of 24 degrees. Oops, wrote that degree sign in the wrong place. There, okay, and again, if I'm skipping too much, I wrote that over 1, and I equated my cross products. Okay, and so remember what x is. It's the sum of those two things. So x is, it's a plus b, okay, but a is 3 divided by the tangent of 43 degrees, and plus 3 divided by the tangent of 24 degrees. And see, that's the exact answer right there, okay? But then to get the approximate, see, you can type that in all at once, and then you don't have to worry about any kind of rounding error. So I'm just typing in 3 divided by tangent 43. Close the parentheses. Remember to close those parentheses right there on your calculator. All right, and then plus 3 divided by the tangent of 24. All right, and then hit enter, and you'll get that approximation. Say I told you to give it to 2 decimal places. If you hopefully you calculated that, and you can see that actually rounds to 9.96. All right, like that. And then again, you got to look back. If you're unaware, whenever you're talking about distances, see, notation can be repetitive. We used this notation for minutes earlier with angles, but now we're talking about a length, so that's notation for feet. I wish it were always a little cleaner, but it's just not in practice. And so anyway, there's the answer to that problem. All right, so a very common use of trigonometry is when dealing with what are called the regular polygons. Okay, so these are straight-sided figures where all the lengths are equal to each other, all the outer lengths are equal to each other, and all the inner angles are equal to each other. Okay, and so there's special names for them, and you can look them up based on how many sides there are. But this is a 5-sided regular polygon, and so we call that a pentagon. All right, so and it tells you that it's regular means same, equal sides, equal angles. Okay, so a regular pentagon is pictured, and I want to find its perimeter. Now, the idea here is that this point is drawn at the center. I may not have drawn that in perfectly. I was having trouble getting my drawing program to do it for me. Okay, so but anyway, so this looks like a very tough problem. Okay, well now first of all we got to remind ourselves what we mean by perimeter too. So remember, perimeter is the distance around the object. All right, and so basically we're asking, if I started at this point right here, and I started walking all the way around it, then how far would I have traveled? Okay, now since our units are in centimeters, it'd be hard to kind of walk it, but you get the idea of what I'm talking about. All right, and so what we're trying to do now, we got to remember though, we have a regular pentagon, so all the lengths are the same, those side lengths. So let's just call one of them x. All right, and then if I know x, then the perimeter is just going to be 5 of those x's. Okay, so the problem just got a little bit simpler. All we have to do is find that x. All right, but it still looks pretty tricky. Okay, but this is something you can always do with regular polygons, is you can take your center point and draw the line that goes out. These are called the vertices. All right, and so you can draw a line that goes out to one vertex and then draw a line that goes out to the next vertex. And I could have just as easily drawn here. Okay, and let me go ahead and draw 5 of these so that you can get an idea about what's going to happen. All right, and see, one key thing here is that it would be nice to know this angle right here. All right, and that might seem a little onerous at first, but remember, a full circle is 360 degrees. And so what have I done is I've taken a 360 degree angle and broken it into 5 segments. So let me give that angle a name. Let's call that theta. All right, and so that angle theta is going to be 360 degrees divided into 5 segments. And so that's going to be 72 degrees. Okay, now be very careful though. So what we're looking at now, we're looking at this kind of picture. Here's x, this side is 5, this is 72 degrees. What's the problem with what we know about trigonometry so far? If you look, there's no right angles there. We need a right angle in this picture. Okay, and so the main way to get a right angle is just to draw this line that goes down to the over to the side x. That's an altitude that forms a right angle. Okay, that altitude is going to cut that angle in half, and so if I go and divide that by 2, I get 36 degrees. All right, and so now we're down to this picture right here. We have a right triangle now. This is 36 degrees. Sorry, I didn't draw that very well, but that angle there is 36 degrees. Okay, and this side length is 8. Now, this is a straight side. That's not also 8. Be careful. Okay, now also be careful too. Why would I say that this is no longer x? This entire length right here is x. All right, and what did we just do? We cut it in half. And so this is actually x over 2. All right, but now we have a right triangle. Okay, now we can get to solving. Here's my right angle, so that 8 is going to be the hypotenuse. Okay, and then the angle that I know in that right triangle is right here, and this side over here is the opposite side. We don't really need it, but sometimes we are solving for that, so that would be the adjacent side. All right, but what's the idea? Okay, let me erase this right here. I'll write it up above to remind us what we need to do at the end, but the perimeter is going to be 5x. Okay, so, and just to give myself a little bit more room, let me make this picture and make things a little bit smaller there. I didn't know I was all going to. So I'm going to redraw things so that we can see things, but we have our right triangle here. This is 36 degrees. This is x over 2, and it's the opposite side. And then this is 8, and it's the hypotenuse. And over here is the adjacent. In this problem, we don't need the adjacent. All right, and so what do we do here? We want the opposite, and we're given the hypotenuse. What trig functions relates the opposite and the hypotenuse? That would be the sine. All right, and so now we write the definition. Sine of theta is the opposite over the hypotenuse. And now we fill in numbers. So we have our angles 36 degrees. The opposite is x over 2. Don't worry that it's a fraction. We'll deal with that in a minute. Over 8, but it works almost just like normal. We do our cross products, so that would be 8 times the sine of 36 degrees equals 1 times x over 2. So that's just x over 2 now. And we're used to that being x. But now we have a proportion again, if that 2's bugging you. So I would write that over 1, and I would equate my cross product. So look at this carefully. I'm going to multiply 2 times this quantity right here. And so I'm going to have 2 times 8. Okay, so 2 times 8 is 16. And then I get the sine of 36 degrees. And that's equal to 1 times x, which is x. So now we know that side length, x. All right, and so we're basically there. And you just got to remember what we were trying to do. The perimeter is 5x. Okay, so that's 5 times 16, the sine of 36 degrees. With that, 5 times 16 is 80. So the exact answer for the perimeter is 80 times the sine of 36 degrees. And say I told you to approximate that to 2 places, then I would have 80 times the sine of 36 degrees. I'm just typing that in, and I get 47.02 to 2 places. Okay, now you need to ask yourself, what kind of units do you have here? We're talking about perimeter. That's the length around, so it's a length. And so it has the same units that we started with. Huh, kicking myself though. I know. Oh yeah, I was right. We got to be careful here. Are there any units given? I started to say there's no units because I didn't have any. Look back at this picture though. That little radius kind of thing was 8 centimeters, and so our perimeter is approximately equal to 47.02 centimeters. All right, so let's look at a basic application now. And so people that use angles and trigonometry a lot are surveyors. And so say a surveyor wants to measure how tall a certain building is. Okay, and so this surveyor stands 100 feet from the building and uses what's called a transit. A transit is a tool for measuring angles. And so it measures the angle to the top to be this angle right here in DMS. Okay, and so let's say the transit is 5 feet tall. Okay, then how tall is the building? All right, so that's the idea here. You might want to pause and digest it and make sure you get everything, because I'm going to shrink down the wording to have a little bit more room to work. Okay, and so let's see if I can do that. Okay, that should be enough room, hopefully. Okay, so again, anytime you have a kind of a diagrammatic problem, you probably want to try to draw some kind of picture to at least get started. Okay, and so let's imagine here's the ground, and then here's our building. Okay, like that. And then now you got to be careful because that transit is 5 feet tall. So that transit is 5 feet tall, and then that transit's measuring the angle to the top. Okay, now make sure you realize too, we're standing 100 feet from the building. So this length right here is 100 feet. All right, and so it's going to measure a straight line distance to the top of that building. Okay, for now, let's just, I'll talk in a minute about how we can get access to this angle easily. You've done it in the homework, but let's see if you remember. So anyway, instead of writing out that angle right here, I'm just going to call it theta. All right, so what do we want to do to be able to solve this problem? Hopefully you see we want to be able to get this distance right here. Okay, like that. And then, so whenever I'm talking about this distance, I'm talking about the distance right here to right here. Now that's not going to be the full height of the building, because then back down to the ground, there's another 5 feet. So the height is going to be x plus 5. Okay, now to get to x, let's just draw the right triangle to make sure we see that. And so we have this right triangle here, like that. And so in that right triangle, this is x, this is 100. Here's our angle theta. Remember, we know theta though, okay? It's not an unknown angle. It's this angle right here. All right, and so so for now, let's just set this up normally here. So here's our right angle. It's the hypotenuse. Here's the given angle, and x is its opposite side. And so then the third side, which would be the 100, is the adjacent. Okay. Also keep in mind that the 100 is in feet, so our answer will be in feet. All right. So so what's the idea here? Is that we're given the adjacent, and we want the opposite. Which trig function relates adjacent and opposite? That's going to be the tangent. Okay, so we first, following our normal format, we write the definition. Tangent of theta is opposite over adjacent, like that. And then we can actually fill in our angle here. So we have 71 degrees, 16 minutes, and 27 seconds is equal to the opposite, which is x over 100, like that. Okay, now so now to solve for x, we just write that over 1, and you notice we're going to be multiplying by 1 over on the right, so we're going to get x. So we have 100 times the tangent of this angle, right? Now how are we going to type that in on our calculators though? I have trouble getting it to do DMS forms. There is a way, but uh, I think I'm just being blockheaded because I know another way to do it. What we can do is we can convert this into decimal degrees, and we don't have to do it separately. So remember, whenever we talked about angles, we said to go to decimal degrees, you say the degrees plus the minutes over 60 plus the seconds over 3600. So whenever I go and plug this in on my calculator, I'll just type in 100, I'll say tangent, and then I'll put parentheses and I'll say 71 plus 16 over 60 plus 27 over 3600. And I just type that in on my calculator. Okay, like that. And then also I'll even do this all in one step. If I want to get to the height of the triangle, remember, or I'm sorry, of the building, then we need to add 5 to that. So it's going to be x plus 5. So what I'll do is I'll go and type this in. I'm just going to get the answer. I'm going to type this in. I'm going to close those parentheses. And then I'm just going to type in plus 5 and then hit enter. All right. And so that's what I'm doing right now. I'm typing in 100 tangent of 71. Oops, almost typed 70. 71 plus 16 over 60 plus 27 over 3600. Then I close my parentheses and then I type plus 5. And that's going to give me my height. And you can see there that rounds. We get 299.999 and so we can see that that's pretty good evidence that the height is probably 300. I'll put a approximate mark there, and so that's 300 feet. All right. Okay, so I hope that makes sense. We're getting our first foray into trigonometry and how we can start using it to solve problems. And like I've said before, we can use trigonometry to solve all kinds of geometric problems. And so we're just starting to scratch the surface. Some of them are pretty basic, like we just saw in the video, and especially once we talk about more general type of triangles, we can use trigonometry to solve all kinds of geometry problems that are practical in the world. Okay, so I hope that helps. Let me know if you have any questions, and all the best.